Dear students, I am your course tutor Narayanasamy Rajendran. I would like to introduce this course ITNT 201 Routing and Switching Essentials. In this course, there are 8 modules are there. The first module is about basic device configuration. The main objective of this topic is how to configure the devices like routers and switches using security best practices. There are 5 topics in this module. We will see the topics as well as its objective. The first topic is configure a switch with initial setting. The objective of this topic is how to configure the initial settings on a Cisco switch. The second topic is configure switch port. The objective of this topic is how to configure the switch port to meet network requirements. The third topic is secure remote access. The objective of this topic is how to configure the secure management access on a switch. The fourth topic is about router, basic router configuration. The objective of this topic is how to configure the basic settings on a router to route the packets between two directly connected networks using command line interface CLI. Finally, the last topic is about verified directly connected networks. The objective of this topic is how to verify the connectivity between two networks that are directly connected to the router. We will start with the first topic in module 1. In this topic, we are going to discuss about how to configure a switch with initial settings. In this, we are going to discuss about switch boot sequence. Before getting into this topic, first we should understand what is booting and what is boot sequence. Booting is a startup sequence that starts the iOS operating system of a switch when it is powered on. A boot sequence is the initial set of operation that the switch performs when it is powered on. Every switch has a boot sequence. As I said earlier, after a Cisco switch is powered on, it goes through the following 5-step boot sequence process. As a first step, the switch loads the power on self-test program from ROM to RAM. The post program is responsible for checking whether the CPU systems are working properly or not. It tests the CPU, DRAM, and the portion of the flash device that make up the flash file system whether they are working properly or not. Once the post operation is successfully completed, then it initiates the second step. The objective of the second step is to load the bootloader software from ROM to RAM. Once it is successfully loaded, then it initiates the third step. The objective of the third step is executing the bootloader software. The bootloader performs some low-level CPU utilization. It initializes the CPU registers, which controls the physical memory is mapped, the quantity of memory and its speed. Once it initializes the CPU registers and the memory, then the fourth step is initiated. The objective of the fourth step is to initialize the flash file system on the system board. In step 4, the bootloader initializes the flash file system on the system board. Once it is done successfully, then it will start the last step. It will initiate the last step. In the last step, the bootloader locates the default iOS operating system software image and loads that software image into the memory and gives the control of switch. What is the use of boot system command? If multiple versions of Cisco iOS image versions are stored in the switch, then the boot system command is used to specify which iOS images to boot from. Also, it is used to set the order to try them in if it has a trouble booting. Actually, the booting sequence process automatically boots the iOS image by using the information stored in the boot environmental variable. If the boot environment variable is not set, the switch attempts to load and execute the first executable file it can find. Say, for example, two different versions of iOS image files 150-1 and 150-2 are available in the switch. If you want to know which iOS image is loaded currently, then you have to use the show boot command in the privilege exec mode. By default, the switch starts with a particular iOS version. For example, 150.-1. But you want to start the switch with a particular version 150-2. If you want to start the switch or boot the switch with the particular iOS version, then you have to assign the boot environmental variable. To set the boot environmental variable, you have to use the boot system command. So the boot system command is used to set the boot environmental variable, which in turns specify which iOS image version should be loaded during boot sequence process. For that, we will see this example. If you look at this example, in the example, you can see the command s1 config hash. So you know that s1 represents the device name, that is switch 1. Config hash represents the global configuration mode, followed by the boot system command. The boot system command is divided into four parts. The first part is the main command. Boot system is the first part, which is the main command, followed by the second part. Second part, the command is flash, which represents the storage device. We know that the iOS image versions are stored in the flash memory. So the second part represents the storage device, that is the flash. Then the third part of the command represents the path to the file system. And finally, the fourth part represents the iOS version file name. So if you see this, this command is divided into four parts. The first part, boot system, the main command. The second part, flash, it represents the storage device. And the third part represents the path to the file system. And the fourth path represents the iOS file. In Cisco switches, the LED lights are used to monitor its activity and its performance. Different LED lights are used to represent different characteristics and status of the switch. There are six LED lights are there. Each LED light is represented with an acronym. The LED lights are system LED, redundant power supply LED, port status LED, port duplex LED, port speed LED, and power over Ethernet LED. If you see the switch, each LED light is represented with an acronym. SYST. This represents the system LED. RPS. This represents the redundant power supply LED. STAT. This represents the port status LED. Duplex. This represents the port duplex LED. Speed, which represents the port speed, and PoE, which represents the power over Ethernet. So these acronyms are used to find out the LED. Now we will discuss briefly about each LED, the usage of each LED. First, we will take the system LED. The system LED, which is used to find out whether the switch is working properly or not. If the LED is off, the system is not powered on. If the LED turned on, when it is green, the switch is operating normally. When the light is green, blinking green light represents the system is loading the software. When the system entity turns amber, system is receiving power, but it is not functioning properly. When the amber blinks, the blinking amber represents that there is a fault in one of the following area. Like it may be, the problem may be network module or non-traffic related, or it may be a power supply, or it may be due to fan module. So the system LED shows whether the system is receiving the power supply or not, and whether it is functioning properly or not. So that is the usage of the system LED. RPS, redundant power supply LED, which shows the RPS status. So what is RPS status? So redundant power supply system. In Cisco, in Cisco, the RPS 2300 is a system which offers the enhanced capabilities to manage power supply redundancy among the devices. The RPS system delivers the power supply redundancy and resiliency for a variety of power requirements, including PoE. It helps to ensure the uninterrupted operation and protection against device power supply failures. The RPS LED in the switch indicates that whether the switch is connected with the RPS system or not. If the light turns on, that means the switch is connected with the RPS system. If the light turns off, it is not connected with any RPS system. The port duplex LED represents the switch port mode operation. Whether the switch port operates in the full duplex mode or in the half duplex mode. If the port duplex LED is off, it means the port is operating in half duplex mode. If the port duplex LED is green, then the port is operating in full duplex mode. So basically, you know the difference between half duplex mode and full duplex mode. Full duplex mode represents that the port send and receive the data at the same time. Half duplex mode represents that the port send and receive the data but not at the same time. A port speed LED, which represents the speed of the port. A port can be configured in different speed. For example, it can be configured in a 10 Mbps speed or 100 Mbps speed or 1000 Mbps speed. So, how to identify in which speed the port operates? For that, we can use the port speed LED. If the port speed LED is off, that means the port is operating at 10 Mbps speed. If the port speed LED is green, that means the port is operating at 100 Mbps speed. If the port speed LED is blinking green, that means the port is operating at 1000 Mbps speed. Port status LED displays the link status and the activities of each port. If the port status LED light is off, the port does not have a valid link. If the port status LED is steady green, the link is up and there is no traffic. If the LED is flashing green, the link is up and the traffic or packets are transmitted or received. If the LED is steady amber, in error or out error. The PoE LED, which represents the PoE status of the switch. If the PoE LED is off, the PoE is turned off in the switch. If the PoE LED is green, the PoE is on. The port LED is green only when the switch port is providing the power. If the PoE LED is off, it means that it is receiving the power from an AC adapter. It is not receiving the power through the Ethernet. In Cisco switches, LED lights indicates the status of different operations. The status of each operation is represented by using different colors. Say for example, green, blinking green, amber and blinking amber. These are all the different LED light colors are used to represent the different operation of different status of different operations. If you look at this uh, table, you can easily understand the status of each operation by using the LED light. For example, if the RPS LED is off, it means the RPS is not ready or it is not connected with RPS system. If the RPS LED is green, meaning that the RPS system is ready. If the RPS LED is blinking green, meaning that the RPS is working but not available at the time, maybe busy or connected with other system. We know that RPS system maybe it is able to connect with the two systems at a time. So if RPS LED is amber, meaning that the RPS is in standby mode or in a fault mode. If RPS LED is blinking amber, meaning that the switch internal power supply fails and it is getting the power from the RPS system. In the same way, if PoE LED is off, means the switch has not selected the PoE for operation. If PoE LED is green, meaning that the switch has selected the PoE for operation. If port status LED is off, meaning that no device is connected or maybe the port is shut down. If the port status LED is green, meaning that the link is up or some device is connected in that port. If the port status LED is blinking green, meaning that the link performs some activity by sending and receiving the data. If port status LED is amber or blinking amber, meaning that the port is blocked or it is preventing the loop. If the port status LED is alternating amber and green, meaning that there is a fault in the port. If duplex LED is off, meaning that the port is operating at half duplex mode. If the duplex LED is green, meaning that the port is operating at full duplex mode. If the speed LED is off, meaning that the port is operating at 10 Mbps speed. If the speed LED is green, meaning that the port is operating at 100 Mbps speed. If the speed LED is blinking green, meaning that the port is operating at 1000 Mbps speed. If if PoE LED is off, meaning that PoE mode is not activated or it is in off. If PoE LED is green, meaning that the PoE mode is activated or it is on. If PoE LED is amber, meaning that the PoE mode is disabled. If PoE LED is blinking amber, meaning that the PoE mode is off due to fault. If PoE LED is alternating amber and green, meaning that PoE mode is denied over budget or availability. How to recover a switch from a system crash? Sometimes the switch fails due to iOS crash or missing or damaged system files. In that case, the switch cannot perform any operations. So we have to recover the switch from the crash. How to do that? The only method is reinstalling the iOS. If you ask, already the switch is not working, then how it is possible to reinstall the iOS? Actually, the bootloader provides access into the switch if the operating system cannot be used or it fails. The bootloader command line supports commands to format the flash file system or reinstall the operating system software, that is iOS image, and recover the lost or forgotten password. So in case if you forget the password, if you lost the password of a switch uh, for the privilege exe mode or user exe mode console password or something, then you can access the switch by using the bootloader. You can recover the forget password or you can recover the password, last password or forget password. So there is an option. In the same way, the bootloader can be used to reinstall the iOS image. The bootloader has a command line that provides access to the files stored in the flash memory. We know that iOS images are stored in the flash memory system. So using bootloader, we can access that. The bootloader can be accessed through a console connection using the following steps. So we are going to access the bootloader of the switch by using a console connection with the help of the PC. Okay, so we have to follow the procedure. So first step, we have to connect a PC by a console cable to the switch console port. Second, next, we have to configure the terminal emulation software. We know that putty, teratam, hyperterminal, these are all the terminal emulation software. Using this software, we have to connect to the switch. Step 2, we have to unplug the switch power card. Step 3, we have to reconnect the power cord to the switch, and within 15 seconds we have to press and hold down the mode button. while the system LED is still flashing green. Step 4. We have to continue pressing the mode button until the system LED turns briefly amber and then solid green. So then we have to release the mode button. The bootloader switch prompt appears in the terminal emulation software on the PC. So once we are able to get the prompt in the PC, then by using the commands, DOS commands, we can navigate and we can see what are the files available. For example, the directory command can be used to view the list of files available in the file system. So in the same way, we can reinstall the iOS image, and we can recover the lost password or forgotten password from the configuration files. Switch management access. Why we need a remote management access? Remote management access allows you to access and manage the switch from a remote location via the network. How to prepare a switch for remote management access? For that, the switch must be configured with an IP address and subnet mask. The switch has the SVI switched virtual interface. We have to configure the IP address and subnet mask for the SVI. Switched virtual interface is an virtual interface. It is not a physical port on the switch. For example, if you want to manage the switch from the same network, then you need only the IP address and subnet mask. If you want to manage the switch from the remote network, then the switch must be configured with the default gateway address apart from the IP address and subnet mask. So the IP address and subnet mask should be configured for the SVI switched virtual interface on the switch. So how to configure this IP address and subnet mask in SVI? For that, we need a console cable. The console cable is used to connect the switch and the PC, and then we require the terminal emulation software like Putty, Teraterm, or Hyper Terminal. Okay, we need some terminal emulation software. So from the terminal emulation software, we have to access the CLI of the switch, and then we have to configure the IP address and subnet mask. We have to configure the IP address and subnet mask for the SVI. Switch SVI configuration example. We know SVI, switch virtual interface. It is a virtual interface which is used to manage the switch remotely. So to manage the switch remotely, we have to assign the IP address and subnet mask for the switch virtual interface. In a switch, by default, VLAN 1 acts as a management VLAN. All the ports in the switch are assigned to VLAN 1 by default. So in general, the IP address and subnet mask for the SVI is configured to VLAN 1. But using a separate VLAN other than VLAN 1 for management VLAN is safe and secure and also considered as a best practice. How to configure the default VLAN with IP address and subnet mask? So for that we have to follow the step. We have to configure the management interface from VLAN interface configuration mode, that is interface VLAN 1. So in the global configuration mode, we have to enter the command interface VLAN 1 followed by the command IP address, and we have to enter the IP address followed by subnet mask. So and we have to enter the command no shed. The next thing is how to configure the management VLAN. To configure the management VLAN, first we have to create the management VLAN. So how to create the management VLAN? So we have to create, for example, I want to assign the ID 99 for management VLAN. I want to create VLAN 99 as a management VLAN. So first I have to create VLAN 99. The next line we have to assign a name management. So the management VLAN is created. After creating the management VLAN, now we have to assign the IP address. So interface VLAN 99 and then IP address, and then we have to assign the IP address and subnet mask and no share. So in this way, we have to assign the IP address for the default VLAN as well as the management VLAN. As I said, the if you want to assign the management VLAN, first you have to create the management VLAN because the management VLAN will not be appear by default. So first you have to create the management VLAN and then you have to assign the IP address. In case if the switch may need to configure for IPv6, in that case, you have to use the following command in the global configuration mode. The command is sdm prefer dual IPv4 and IPv6 default. After executing this command, you have to reload the switch. Then only you can use simultaneously the IPv4 as well as the IPv6 in the switch. Let us see the commands to configure the SVI in the switch. The SVI is configured in the global configuration mode. So you know that there are four basic modes and two sub configuration modes are there. The first one is user exe mode, privilege exe mode, global configuration mode, and specific configuration mode. Inside specific configuration mode, we have interface mode and line mode. Okay, so S1 hash, you know that S1 hash represents the privilege exe mode. So if you want to configure the VLAN, it should be done in the global configuration mode. So to move from privilege exe mode to global configuration mode, we have to execute the command configure terminal or conf, short form, conf t, conf space t, or the full form is configure space terminal. So this is the command used to move from the privilege exe mode to global configuration mode. So once you reach the global configuration mode, you have to enter the interface configuration mode. So how to enter the interface configuration mode? For that you have to enter the command interface VLAN 99. I already said that. So VLAN 99 is the management VLAN. Already in the previous slide I explained that we created this VLAN 99 for management purpose. So you have to enter the interface configuration mode. So to enter into the interface configuration mode, you have to execute the command interface VLAN, that VLAN ID, VLAN 99. So don't think that only we have to use 99. Any ID you can use. Okay. The next thing is you have to configure the management interface IPv4 address. So for that VLAN 99, we are going to assign the IP address. So how to do that? For that we have to use the command IP space address followed by the IP address as well as the subnet mask. In this example, the IP address is 172.17.99.11 and then the subnet mask is 255.255.255.0. So now we have successfully assigned an IPv4 address to the VLAN interface 99. In the same way, if you are going to use the IPv6 addressing in your network, if you want to assign the IPv6 address for this management VLAN interface, for that you have to use the command IPv6 address followed by the IPv6 address. In this example, the IPv6 address is 2001 colon db8 colon acad colon 99 double colon 1 slash 64. So this is the IPv6 address assigned. So if you see this example, we have assigned an IPv4 address as well as an IPv6 address for this interface VLAN 99. So if we are not going to use the IPv6 address, it is optional one. If you are going to use, then only you have. It is not mandatory. IPv6 address configuration is non-mandatory. It is optional. In your network, if you are going to use IPv6, then it is required. Unless, no need to configure that. So then you have to enable this, activate this interface. How do you enable this interface? By using the command no shut. Finally, you have to N, and then you have to save this configuration. To save the configuration, you have to go back to the privilege exe mode, then you have to execute the command copy run start, or from the same mode, from the interface mode itself, you can save either by using do wr or do copy run start. Okay, so now I want to tell you one important thing. In this example, we configured both IPv4 as well as IPv6 address for this interface VLAN 99. So I already said that if you are going to configure IPv4 and IPv6 address for this interface, you have to configure the command SDM prefer dual IPv4 hyphen and hyphen IPv6 default. So if you and then you have to reload the switch after configuring the stm prefer command. You have to reload the switch. See, then only you can configure the IPv4 and IPv6 address to the management VLAN. So don't forget that if you want to configure both IPv4 and IPv6 address for the SVI, you have to configure the command stm prefer dual IPv4 and IPv6 default. This command is important. Now we'll discuss how to configure the default gateway for the switch. I already said that if you are going to manage the switch within the network, default gateway address is not required. If you are going to manage the switch from the remote network, then the default gateway is required for the management access, remote management access. So now we will see how to configure the default gateway address. You know that the default gateway represents the router. The switch is connected to a router. That router will act as a default gateway. First, you have to find out the IP address of the router. Then you have to configure that IP address as a default gateway address in the switch. Right? So now first go to the switch. Now you are in the privilege exe mode. S1 hash represents the privilege exe mode. Execute the command configure terminal to reach the global configuration mode. Once you reach the global configuration mode, you have to configure the default gateway. To configure the default gateway, we have to use the command IP space default hyphen gateway. So default hyphen is a single word. So IP space default hyphen gateway space the IP address of the router. So in this case, the IP address of the router is 172.17.99.1. Then N. Finally, you have to save the configuration by using the command copy run start. So now, after configuring the IP address for the interface, we have to verify whether we have configured the IP address properly or not, whether the IP addresses are assigned properly or not. So to do that, we have to use the command. So if you want to verify the IPv4 addressing, you have to use the command show IP interface brief. If you execute the command show IP interface brief, it will give the information about the interface, IP address, OK, method, status, and protocol. If you see the if you see the uh, output of the show IP interface brief, you can see VLAN 99. That is the interface name. That is the management VLAN we created. For that, we assigned the IP address 172.17.19.11. I think you remember that this address we assigned in the last slide. Okay, then it is okay. Yes, it is assigned properly. So how it is assigned? Method represents whether it is assigned manually or automatically. Automatically means by using the DHCP. Okay, the next thing is status. Status may be up or down. So in this case, the status is down. It is not activated. And then the protocol is also down. Okay. So now in the same way, if you want to verify your IPv6 address, you have to execute the command show IPv6 interface brief. If you execute the command show IPv6 interface brief, then it will show you the IPv6 address assigned to the VLAN 99. The important thing is there is a note here. An IP address applied to the SVI is only for the remote management access to the switch. This does not allow the switch to route the layer 3 packet. That means once you assign the IP address for the switch, you should not think that the switch will forward the packets, or you can communicate, or you can this SVI address can be used to forward the packets. No, SVI addresses are used only for the remote management access. We cannot, this IP address, this SVI address cannot be used to route any layer 3 packet. In the next part, we will discuss about configure switch ports.